In this video, I will show you how to find the area of the polygon whose vertices are given using matrices. First, let's go ahead and just graph these vertices so we can see the polygon that we are looking for. So for example, -7, -6 is going to be right here. Okay, let's label that. So we have -7, -6. And I'm just going to graph all of these points in the same way. Okay, so here's the polygon that we need to find the area of. The first step is to split the polygon up into triangles. So just pick a vertex and start drawing diagonals that will form triangles. So if I go like this, I see that my first triangle, and I'm just going to keep going using the same starting vertex over and over again. And in that way, I've taken my polygon and I have now split it apart into 1, 2, 3, 4 triangles. So basically now we just need to find the area of each triangle and add them up. Okay, so here's the part where I tell you how to use matrices to find the area of a triangle. Okay, so look at triangle number 1. Let's go ahead and make a matrix out of these vertices. So my first vertex is -7, -6. So here I have -7, -6, and then -10, 2, and then -9, 8. All right, so these are the 3 vertices of the first triangle. Now I need to turn this into a square matrix, a 3 by 3 matrix, by adding a third column, all ones. Okay, so this is going to be my my first matrix, and so I'll just call it matrix number 1. Now I'm going to go ahead and put the vertical lines around this matrix to show that what I need to do now is calculate the determinant of this matrix. These vertical lines mean the determinant. So how do I calculate the determinant of a 3 by 3 matrix? What I need to do is pick a row. Just pick the row that seems to have the smallest numbers in it. So I'm going to pick the top row. Okay, now I'm going to be using the following pattern. Maybe I'll put the pattern up here. The pattern goes plus, minus, plus, minus, plus, minus, plus, minus, plus. Now I picked the top row, so that's going to follow the pattern plus, minus, plus. Now what am I talking about? All right, well, first thing, we have something called cofactors. Each one of these numbers, the -7, the -6, and the 1, is called a cofactor. So if I want to find the determinant of this matrix, I start with these cofactors. So I'm going to start with the -7. All right, and then I'm going to form a smaller matrix that will be formed in the following way. I'm going to ignore the row that I'm dealing with, but I'm also going to ignore the column. So right now I'm talking about the -7, so I'm going to also ignore the first column. Now look what that leaves behind. That leaves behind the 2, 1, 8, 1. So this is called a minor matrix. So we have the cofactor and then we have the minor. So notice I'm still using the vertical lines, which means I'm still doing the determinant of this little matrix, this minor matrix. Now, here's where the plus, minus, plus comes in. These cofactors, sometimes we will keep the sign the same, and sometimes we will change the sign to the opposite. And basically, wherever you see a plus, that means leave the sign alone. When you see a minus, that means you need to do the opposite. So for my next cofactor, I've got the -6. But because of this minus, I'm going to change the sign to a +6. All right, so I'm going to do a +6 cofactor. And now for the minor matrix, okay, I'm still dealing with the top row, but now I am going to ignore the middle column where the -6 is. That leaves the minor matrix -10, 1, -9, and 1. So now I will move on to the third cofactor, which is a +1. And because of the plus right here, that means leave the sign alone. So I'm going to leave it a +1, and then I will do my minor matrix by canceling out that column. That leaves the minor matrix -10, 2, and -9, 8. Okay, so now what do I do? What I have is -7 times this determinant. The determinant of a 2 by 2 matrix is the down diagonal minus the up diagonal. So here my down diagonal, if I multiply those, that's going to be 2. And I need to subtract the up diagonal. 8 times 1 is 8. So I've got 2 minus 8. All right, so I'm just going to do that a couple more times. So here I've got my 6. My down diagonal is -10. Okay, and I need to subtract the up diagonal. The up diagonal is -9. Minus -9 is actually going to be +9. Okay, so when you have minus negative, it turns to a plus. And then I have the 1, and I have the down diagonal minus the up diagonal. So the down diagonal is -80. Okay, minus the up diagonal is -18. So it's going to wind up being +18 because minus -18 is +18. Let's keep going. So I will have -7. All right, so 2 minus 8 is going to be -6. Then I will have 6 times, and then -10 plus 9 is -1. All right, and then I have 1 times -80 plus 18. So that's going to be -62. All right, so that's going to give us 42 and -6 and -62. So that's going to give us -26. Now I went ahead and wrote down determinant of matrix 1, since that's what we've been doing this whole time, is calculating the determinant. So now there's one extra step to find the area of triangle 1. So now that we have the determinant, the area, so I will just call it area 1, is going to be 1/2 of this. Okay, but see how this is a -26? Areas cannot be negative. So if you get a negative determinant, just go ahead and put a positive number. All right, and that is going to give us the area of the first triangle. So the area of the first triangle is 13 square units. All right, so basically we need to repeat that process 3 more times. I'm not going to do all that work on this video. I think what I'll do is I'll do one more triangle on camera, just to make sure we have that little process down. And then I'll do the rest off camera. So I'm going to go through it a little bit faster this time because I think you basically get it. All right, so let's talk about triangle number 2. The vertices are -7, -6. So we're in the process of finding the determinant of matrix 2 right now. Okay, so we're starting with -7, -6. And then we have -9, 8. And the third vertex is -5, 10. And we will finish off the matrix with 1, 1, 1. So we need to find the determinant of this. Let's pick a row, and I think I will just use the first row again. It doesn't matter which row you pick, we're just going with the smaller numbers. And we will use these 3 numbers as the cofactors. So I will have the -7. Don't forget, we're using the pattern plus, minus, plus, which means we keep the sign, change the sign, keep the sign. So I will keep the -7, and I'm going to do the minor matrix now by also canceling out the first column. And that's going to give me 8, 1, 10, 1. Okay, now we will use the -6, but that one we change because of the plus, minus, plus. We change this one to a +6. All right, and if we sort of cross out that column, that leaves us with -9, 1, -5, 1. Okay. And finally, we will do the third cofactor of 1. And then the minor matrix will be the -9, 8, -5, 10. Okay, so the determinant of matrix 2 will be -7 times down diagonal minus up diagonal. So that's going to be 8 minus 10. Down diagonal is -9. The up diagonal is -5, but minus -5 is +5. Down diagonal is -90. Up diagonal is -40. So I'm going to wind up having +40 because minus and negative is positive. All right, so this is how we calculate the determinant of matrix 2. So this will be -7 times -2 plus 6 times -4 plus 1 times -50. All right, so the determinant of matrix 2 is going to equal +14 minus 24 minus 50. So the determinant is -60. So that means if I want the area of the second triangle, I'm going to do half of this, and I'm going to ignore the negative and always put positive. So the area of the second triangle is 30. All right, so we have the area of the first two triangles. We just need to do the same thing again for triangle 3 and triangle 4. I think I'm going to speed this part. I'm going to work it all out on camera, but I'm going to try to speed up the video. So we've found all four areas for each of the four triangles, and so to find the final answer, all you have to do is add these up. So the area of the polygon is going to be 211 square units.